Hi everyone, in this video I'm going to be going over combustion reactions, and so this is basically when you set something on fire. So for example, wood, for example, is made up of carbon and hydrogen, which is flammable, and when you combine that with like a match or whatever, and you have oxygen present, you'll get a combustion reaction, which is when a lot of heat and energy is given off, a very big indicator of a chemical reaction. And you will also get carbon dioxide and water as the products. Carbon dioxide is a gas, and then water vapor also in the form of gas as well. So whenever you have these types of reactions, whenever you see these types of reactions, you will always get the same products, which is carbon dioxide and water. So for these types of reactions, you don't really have to do much to figure out what the products are. The only challenging part can be balancing these equations. So let's start with the first one. So we have one carbon here, that's good. We have 4 hydrogens here, 4 hydrogens here, or 2 hydrogens here, so that's not the same. So in order to make them the same, I would add a 2 in the front of this, because 2 times 2 is 4, so now I have 4 hydrogens on both sides. And when you're doing the balancing for these types of reactions, I would always work on the carbon first, the hydrogen, and then work on the oxygen last. That'll just make balancing it a lot easier. And again, you're getting these products every single time you have a combustion reaction. So lastly, we have the oxygen. So I can see over here that there are 4 oxygens. 2 times 2 is 4. Again, the left side will always be balanced for you already. Now, if I look on the right side, oxygen's actually in 2 different places. There are 2 oxygens here, and then remember we put the 2 in the front here, and there was 1 oxygen here. So 2 times 1 is 2. So on each side, this is 4 oxygens here. There's 2 oxygens here plus the 2 oxygens here. That's a total of 4 oxygens. So this equation is now balanced because there's 4 oxygens on either side, 4 hydrogens on either side, and 1 carbon on either side. The next one's a little bit more challenging. So again, start with the carbon first. Here we have a total of 4 carbons because 2 times 2 is 4. And here we have 1 carbon. So to make them the same on either side, I'm going to put a 4 in the front here. Next, I'm going to work on the hydrogen. There's a 2 here, and there's 6 hydrogens here. Again, that 2 in the front gets applied to everything it is in front of. So that is actually a total of 12 hydrogens. So in order to make this side, because 2 times 6 is 12, so in order to make this side have 12 hydrogens, I would have to put a 6 in the front here, because 6 times 2 is 12. Now let's look at the oxygens. So here we have 7 times 2, that is 14 oxygens. And if we look at the right-hand side of the equation, let's see, we have right here, we have the 4 in the front and 2 oxygens here. 4 times 2 is 8. So that's 8 oxygens, plus here we have the 6's in the front, and that gets applied to this oxygen here, which there's just 1. So 6 times 1 is 6. And that gives us 14 oxygens as well. So that's why I suggest doing the oxygens last, because pretty much once you have those carbons and hydrogens figured out, your oxygens will get figured out as well in terms of the balancing.